Good morning, good afternoon, good evening, wherever you are in the world. Welcome back to SurrealDB stream number 35. It's going to be an exciting one today. We've got a lot of demos and exciting stuff to show you. So I'm joined by Samuel, the founder and creator of Pydantic and PydanticAI. And I'm also joined by Martin, who is an engineer here at SurrealDB, working on AI demos and examples and integrations. So for those of you who don't know Pydantic, Pydantic is one of the kind of most downloaded Python projects, and it's been downloaded over more than 300 million times a month. It's now, alongside the AI functionality, it's now a main dependency of many GenAI Python libraries, including OpenAI's SDK, the Anthropic SDK, LangChain, and additional ones from there on in. So for those, Samuel, welcome. Thanks for joining us today. For those of our listeners who don't know PydanticAI, why would a team pick it to run agents in production?
Yeah, good question. Well, first of all, thanks so much for having me. I'll do a minor correction where I think we're at 550 million downloads. So I suppose that is more than 300, but notably so.
It's growing quickly.
I suppose that there are two reasons that practically people use Pydantic AI. One, they've used Pydantic itself, the original validation library, for many years, and they trust our engineering judgment in particular. I guess more and more our taste in AI, but it's really the fundamentals of engineering that's why people know us and trust us. And then I suppose for that precise reason, the kind of engineering correctness of what we do. So we care about type safety. We think type safety is critical for human developers and even more important for AI developers. And so we work very hard to make Pydantic AI type safe wherever it can be. Similarly, on the good engineering quality, we have things like support for durable execution via libraries like Temporal, DBoss, and Prefect, rather than trying to roll our own toy durable execution solution, as certain other agent frameworks have done. We rely on the industry standards. And I suppose there are lots of other examples, but some of them concrete, some of them a bit more subjective, but it's basically that engineering taste and judgment that is what differentiates us. So little tiny things like every single one of our examples in our documentation is linted and tested as part of CI. So there's a half decent chance if you copy paste one of our examples, it will actually run. As we saw just before this, when I copy pasted one of the examples that I'm going to run in a minute. If things are not tested, they're broken, and that is so often the case with examples in documentation. Now, humans might no longer read library documentation, but it's even more important when an AI is copy pasting it and trying it that it's actually correct. So lots of things like that.
Yeah, I think exactly as you just said there. So for the people listening in, watching in, the demos that we're going to be demonstrating for you today have, some of them have been knocked up in a few minutes. I think it's going to show the power of what you can build in 25, 30 minutes, maybe an hour of your time, especially if you're using Python, but generally, to get something working. And I think that brings me back to probably the main point, which is last year was the year of agents. It was the year of people trying out agents, building these connected agents and starting to implement these in enterprises and in startups and things like that. But I think it's safe to say that 2026, people are going to be moving from proof of concepts and little demos into moving into production. So which 2 to 3 features do you find teams rely on most as they move beyond that POC and into production now?
It's a good question. One of the frustrating things about maintaining open source is that you often don't know that much about how people use stuff. So if people are using Pydantic AI, I would love to hear about how they're doing it and what they're doing. I think that a lot of cases come down to some relatively simple fundamentals. So lots of things that look incredibly fancy come down to, from a code point of view, they're equivalent to structured data extraction, even though they might seem more complex than that. If you're analyzing documents to look at sentiment, let's say, that doesn't feel like structured data extraction, but that's what it turns out to be in terms of how the code looks. And obviously, as the developers of Pydantic, that's the kind of stuff that people find particularly important to kind of get reliable. Secondly, I mentioned durable execution already. Once your workflow or your agent is taking more than 30 seconds to run, you really don't want to be hoping that the node doesn't restart during that time, hoping something doesn't go wrong. And so our integration with durable execution frameworks is something I think people don't particularly need in development, but matters a lot once you get into production. What else particularly matters when you get through to production? I had a third thing that I was about to say, and it's completely skipped my mind at this moment. So,
well, it's probably coming on to my next point, which is Pydantic obviously is where your journey started, and then moving on to the AI space as well. But actually, let's talk a little bit about Logfire, because that's what we're going to be demoing today. And observability in the database is a big part of running infrastructure. Observability on the SDK, but it goes beyond that. And this is what Logfire brings. It's that observability across the entire stack. So tell us a bit about Logfire and how that fits into the bigger picture.
Yeah, so it's our kind of working assumption at Pydantic and strong belief that AI is still just engineering. That there's a bunch of people who, for fun and profit, will want to claim that AI is so profound, so incredibly powerful, that we somehow can forget standard engineering principles. And I agree, AI is massive, and I agree that AI is going to write lots of the code that we develop, but there's still engineering. There's still fundamental low-level challenges with networking, with latency, with reliability, with database, with whether that be database latency, network latency, something that occasionally fails. And so, just as we're caring about the engineering quality inside our agent framework rather than chasing the current hype term, similarly, Logfire is a general observability platform with first-class support for AI, because if you're optimistic about what AI is going to do, it makes no sense at all to have an AI observability platform and a general observability platform on a completely different screen that can't talk to each other. So yeah, Logfire is general observability. It is observability for AI, so explaining what your LLM is doing. And lastly, we think that the AI for observability, the capacity to point your AI at an observability problem and get it to figure it out rather than making you trawl through traces, is super important. So we do a bunch of stuff in that direction as well.
And it's brilliant. So we'll be demoing that in both of our examples that we're showing today. I think it makes it so simple to work your way through from the application you're building all the way through to the data and how that works. And I think that's really important, because if you want to succeed in this AI space, you have to get the application, you have to get the data, you have to get that retrieval working well and seamlessly all together. SurrealDB's ethos is, if you bring all of the different modalities together, if you can bring vector with graph, with full text search, with traditional search together, and bring that, have a single search query which runs and can query in a myriad of different ways, then you're going to get better results. You're going to have less latency. You're going to improve the performance, or improve the results that you're getting out. And I think that we've added Logfire integration into SurrealDB Python SDK, which has been great over the last couple of weeks for those of you who've been watching our Python SDK development. But Samuel, one final question before we dive into the demos. Given the stack between a database that can handle different modalities and then Logfire, where do you see the fastest win for teams who adopt both platforms?
I think it is whether it is a human or an AI trying to figure out how to get something to work. Having fewer bits of technology to interact with, fewer things to set up, is obviously a win. It saves time and it gets you to move quicker. And so, just as I've just made the pitch for have one observability platform that's doing AI and non-AI and evals, it makes sense to have one database that can cover multiple different use cases. Postgres has got us an incredibly long way in lots and lots of regards, and it's obviously changed the world. But it doesn't make logical sense that it's going to be the ultimate solution for every single thing. And we all know its shortcomings for all we love a lot of the things it does, and it makes sense as vector becomes more important and as modalities change to have a database that can cover those things without having to piece together the kind of mosaic of different databases that I need in my system.
Yeah, that makes sense. I mean, look, most of our viewers, most of our users want to see demos, want to see things being built or being shown. So let's jump right into that. We're going to start with an example where we're building effectively a very quick chat app which stores information. It queries through vector. We can then go in and see the telemetry of the calls and the data being stored. So let's jump right into it.
Yeah. As we said earlier, this was put together pretty quickly, so you might see things running, being built, and indeed failing as we go along. But I'll talk through this example first. As one thing I just want to change here while I'm thinking about it. I wanted to just make the point that like I'm in Z here with based PyWrite set up fairly strictly, and you'll see we've got no typing errors anywhere here. And if we did have a typing error, if I made a typo, or if I returned the wrong type, we'll immediately see that. If we used an agent framework that abandoned the idea that type safety is important, we would lose that, and that would be really unfortunate. But anyway, I'll stop being rude about LangChain, and I will show you this example. So this is
just to jump in there quickly. AI is about building quickly, right?
Yep.
And but you don't want to introduce tech debt that you have to go and fix 6 months down the line when you go into production, and that's important for a startup, sure. But it's really important for an enterprise, especially when you've got lots of teams building on the same product. So this helps massively with that.
Yeah, absolutely. And the thing that AI coding agents, whether you're using one of the IDEs or whether you're using like Claude Code as I do, the thing they love is type safety. The fact they can go and mark their own homework in a side effect free way is massive in terms of getting them to move quickly and not make all the dumb errors. So we've got a very simple chat app here set up, written in pure HTML. We've actually got a sexier interface for building chat applications that I will show you in a bit. I might actually be able to even switch this example to use it, but I'll run this example. So the actual agent we have set up here, there's nothing particularly exciting. We haven't even given it a system prompt at this stage, but if you look here, we'll run it with run stream, and we're gonna pass it in some messages. So obviously this is the kind of history of the exchange between the LLM and the user. And here we're using, if we look at our database implementation here, if we look at our database, here we're using an embedded SurrealDB database. So this is, please correct me if I'm wrong, but this could kind of fill in for a similar role where you might use SQLite, where you're not having to run a separate process. You've just got SurrealDB, making your queries within the process and then storing files locally on disk. And you can see the queries here. So it's, I don't want to say too much about SurrealDB where you're going to correct me, but I'll say it's SQL-esque, but it's not exactly SQL. Well, I suppose it is SQL, but it's like your dialect, right?
Exactly. Yeah. Perfect.
And we've got a bunch of work here to basically transform the messages into a format that appears in the UI. As I said earlier, I think we have a way better way of building chat apps now, which I'm going to show you in a minute anyway. So I don't want to lean too heavily into that. I'm just going to run this fast API app with UV down here as the final piece. And so I'll stop that example, and if I run UV run main, I'm going to. That's not what I want to see at all. I want to go over here. So this is the app, and actually you can see I've already asked it some questions and got some responses. But I can ask it another question. What am I going to ask it? What countries are next to France? And it will go away, and we don't have any nice progress while it's thinking. But I'll show you that in the example in a minute. And it's given us an answer and yada yada. This is relatively boring. Let's move on to let's look at that in Logfire actually before we get too distracted. So as you will see in my example here, I have set up Logfire. So you see there's very few commands required here to configure Logfire. We just have the import. We have configure. Before I ran my app, I ran UV run Logfire projects use, and the name of my project is demo. So I'm going to set demo, and that has configured. You can see here there's a local file here, local directory here with credentials in it, and that's what it's using to work out what project to send data to. And then I've just gone and instrumented PydanticAI, which will give us the traces from PydanticAI, and instrumented SurrealDB, which should give us the SQL queries, and lastly instrumented FastAPI, so we'll get the HTTP requests. And I think that's pretty much all we've got. We've got one manual span here around connecting to the database. But if you look
just to add, it's all automated, right? So there's very little a user has to do for all that instrumentation. It's kind of like magic in a way that it's just kind of auto instruments everything, and then you can track everything at a later point.
Yeah, and so you'll see here we've used Logfire, and we instrumented Logfire and SurrealDB, but we could also instrument. I mean, you look here. There's an enormous list of other pieces of technology that we can instrument. Everything from like Django, Flask, FastAPI through to LiteLLM. MCP is an interesting one. OpenAI's agent framework, even instrumenting like print commands directly. We did that actually for a PaaS provider who wanted to use Logfire as their default printing, and so their default logging. So if you have a print in their platform, it comes through. And a bunch of other ones, but let me run that. Well, let me show you what that looked like in Logfire. So here are the traces that we got from running that. So we have I showed you that manual trace manual span earlier, and we have the SQL. So this was the manual line where we instrumented where we inserted a manual span, but then we have these spans here coming from SurrealDB. Our SurrealDB's instrumentation are all completely automated, so we can see what queries are being run. We can see the query that was executed and the time it took. You can see we're in the microseconds here because we're within a process. But more importantly, I guess, is showing the chat itself. So you can see we don't have. Here's the one we want to get. So we have a SurrealDB select query retrieving the list of messages. And then we have the agent run itself. So this is where I'm saying PydanticAI is both for, Logfire is both for LLM observability and general observability. But you can see the exchange here that I talked about. Here was where I asked what countries are next to France. Then you can see there was an individual call to, in this case, GPT-5. And so although we have the full exchange here, within this particular agent run, because it was only one step, you see there's just one call to ChatGPT. And then finally SurrealDB inserting the list of messages, which are here. Let me switch over to the other RAG example, which I guess is both more interesting for users, and I think demonstrates some more of the powerful things that SurrealDB can do. So this is adapted from the RAG example in PydanticAI's documentation. And the idea is it's a very rudimentary tool for basically searching Pydantic's documentation. And so we have our agent here. Again, we haven't bothered with a system prompt, although we should probably have one. We're using Claude Sonnet 4.5 as a kind of middling model. And then we've registered a tool here, retrieve, which is allowing us to go and search data. But instead of just doing plain text search, we're doing vector search. So we have a manual Logfire span here around generating the embedding. So this embedder is it's the new PydanticAI embedding library that we're using there. So I think and then so we'll retrieve the result, which is the embedding result, and then the actual embeddings is going to be the list of floats, or the list of floats that represent the embeddings. And then once we have those embeddings, we can then use them as a SurrealDB value in this query, right? So, I mean, correct me if I'm wrong, but the point is here that vector is being substituted in effectively using the parameter. I mean, do you guys want to talk a bit about the details of the setup here? I see KNN, but you tell me exactly what we're doing and how we're doing that query.
Yeah, Martin, jump in and explain that query. I just want to just say before that, for anybody who's interested in this code, it's all open source, so we'll share the links to it afterwards so that you can try it out, hack on it, and see what we've been doing.
Yeah, sure. So here to explain a little bit, these were embedding, and you see the 8 and the 40. Those are the specific arguments for the specific vector index we're using, HNSW. And so basically means we're using 8 is the top K parameter. So we're expecting only 8 results. And 40 is like the effort value. So the higher the effort, the more it's going to take in time, but the more accurate it is. So sometimes 40 is very good, slow. 17 is very fast, but not as accurate. And the first line in the select, where we do vector distance k and n, basically is going to reuse the same distance function that the index was built for. So if the index is using cosine, then this k and n is just getting the cosine distance.
Makes sense. And then I'll carry on talking through. So we have here, we have a type adapter, which is defining our list of retrieval values. I'm sorry, as Pydantic developer, I'm going to have to notice I should have put this outside the retrieve, because there's building the schema, which is a little bit slow here. But the point is here we have a type adapter for list of the query results, and then the point is here we are validating the Python object we got back from the query. And out of interest, does SurrealDB, are we returning returning JSON under the hood from your query, or is it a binary format?
It's binary. So CBOR is what we're using in this particular SDK at the moment, which then it's JSON-like, yeah.
Yeah. Makes sense. I was just thinking if it was actual JSON, we could improve performance by validating the JSON directly, but CBOR makes sense to go to Python and then to validate this way. And in reality, the performance of those things is going to be trivial compared to the rest of what's going on in terms of the LLM. And so then ultimately we have this list of query results, and we're going to format them and return them to the LLM, which can then go and use that to answer the user's question. So this is a very simple example of running the agent. We're just going to call agent.run print result.output, which will be the return text. That'll make more sense when I run this with Logfire and show you what's going on. And then we have some code here related to building the database. So taking the examples and putting them into that database here. So you see database connect, we're creating the schema, and then inserting a bunch in parallel, generating the embeddings and inserting the examples. So we're calling this function, async function here, to do the inserting. We've got a semaphore to limit the concurrency. I've actually already built the RAG database. So that's what you see here. That's this file on disk, as I understand it, SurrealDB, that's where it's storing it. Correct me if I'm wrong. And then there's a bunch of stuff to how we actually got the examples, which is basically trawling through files that I don't think we need to talk about so much. But I'm going to run this in. So I've already run this with the build command to build this file. I want to run it.
While you're running that, let's we've talked about calling the LLM, and I think a lot of developers are just used to calling APIs and things like that. But let's talk a little bit before we show this demo about gateway and what the benefits are for tracking the LLM calls or going through that gateway for LLM calls in production.
Yeah, that makes a lot of sense. So yeah, you'll see where we've defined the two agents the embedder and the agent that we're using. We've got this gateway prefix on the identifier strings. And this means that instead of you having to set up multiple different API keys for OpenAI and Anthropic in this case, everything will go through Pydantic AI gateway. And in this case, I've set it up so that I am, perhaps confusingly in my case, I'm buying the inference from Pydantic. But if you could also set your own keys in here for OpenAI, Anthropic, and the other models. But the point is that then I'm going to open gateway here. And I will show you my keys and my usage. This is for the Pydantic org. You'll see, I guess the 75 cents was me just now generating those embeddings, and you can see this week I've spent $100. But I can, and the point is I've set my limits on the amount I can spend. But we, as well as doing pricing limits and using one API key to connect to multiple different LLMs, I can also trace LLM requests running through the gateway. So I won't show you that right now, but you can do that as well. That's one of the reasons people use our gateway. The other thing to notice, I think it's a really extraordinary situation. There are all of these LLM gateways. They're all centralized, so that if you happen to be near the gateway and the model you're using happens to be near the gateway, you're good. But if you're anywhere else in the world, you have this enormous latency added by going to and from the gateway. Our gateway is distributed, runs on Cloudflare workers on the edge, so you should be, the latency added by using our gateway should be pretty minimal.
And it's about simplification, right? Which is one of the big things of SurrealDB. Just simplified, centralized, and then you can see everything that's going on in a single place.
Yeah, and so all I've had to do to configure using these models is I've set the Pydantic AI Gateway API key, one key, which I can then use for multiple different models. I don't have to think about it. I can set pricing, so I don't have to think about blowing over my budget, and it should just all work. So let me, with that explained, let me go and run the example. So here I'm gonna run a very simple query against the agent. How do I configure Logfire to work with FastAPI? And so if I go and run that, this is the RAG example by default. If I want, I need to add search as an argument, and you will see the trace starting here. I'll see it in the terminal. I'll open Logfire to see it in more details. But you can see this trace here is ongoing. We're at 10, 11 seconds as we're going on. So we're making a second call to Sonnet at the moment. You can see the first call to Sonnet. We had the simple user prompt, and then we had it ran the search query Logfire FastAPI configuration. SurrealDB. Well, we have then used. We've created the embedding. This is, excuse me, let me get myself in the right place. We've created the embedding, and then the point is we take that embedding and we pass that to SurrealDB, which then takes care of running the search. So ultimately, Claude only decided it needed to make one tool call in this particular case. So if we look at the full exchange with the model in this case, we had one tool call. The output of that was this summary of data from different documents within the database. Ignore the fact the images aren't working, and then ultimately that was then passed back to the model, and it was able to use that in turn to build this report, which you can see actually probably in this case looks prettier Logfire than it did in the terminal, but it will also have printed out in the terminal in this case. This is all very well, but one of the other neat features of Pydantic AI is that we support Vercel's AI protocol. So you can just call on an agent to web, and this will give you back a Starlit application. That means you can run your agent as a web interface effectively and use it as if you're using ChatGPT or something, without basically having to write any more code than to web. So if I run this with, I think I've got the uviacorn command here. I'm just running uviacorn, and then I'm pointing uviacorn at RAG and at the attribute of that module app. And with that, we should get this, I think, pretty nice interface for interacting with a particular agent. And so I think we've only got one model set up in this case, but I could configure multiple different models I can use. But in particular, I can go and say, how do I use, what am I going to ask? I'm going to ask, SurrealDB is written in Rust, right?
Yep, fully.
So I would say, how do I use Logfire with Rust? And I'm hoping that our Rust documentation is in the training set. If it's not, we'll at least get to see it running multiple different searches. And so you can see here, we're using Vercel's AI protocol so that we can see individual tool calls as they go on. So you can see here the tool calls that we saw. We made 3 retrieve. We called the retrieve tool 3 times, got back a bunch of different answers. We can see, we can go and look at what happened in those tool calls here. And then ultimately, the agent used that to build this summary of how to go about setting up OTel with Rust. It looks like we have not got our documentation for the Logfire Rust SDK in this particular set, because it has definitely not included. It's definitely told us how to do it wrongly. So we should definitely add our Logfire RS documentation into the training data here. But obviously the other interesting thing is to go and look at what that call I just made looks like in Logfire. So you see, again, we can see the different SurrealDB queries within the tool calls within the agent run. So this was in fact the previous one. That's not come through. Maybe I didn't have Logfire set up for that second case, but you can see from that first run I made that we have, we can see the different tool calls. So the point was we made 2 tool calls in parallel, and then one more tool call. Oh no, this was the right example. Sorry, excuse me. I suppose we didn't instrument the Starlet application, so that's why we don't have in this case the HTTP requests, but we could get them as well. And then we have the full summary here. Does that make sense? Anything else I can cover on this?
No, I mean that's brilliant. I think this is looking at pure vector, and it's demonstrating exactly the ability to kind of see inside your app in production or in development as well, right from, and this is only looking at a couple of layers, but any layer you want, from the very client through to the HTTP call, all the way through back to the data, and how that links up with the LLM. So it's incredibly important when you're coming to build an AI or an application or an agent application, especially sitting on top of SurrealDB or the Python SDK. So this has been really great. We've got one question from Rajan Gupta, and great. Is it new? I assume you're talking about Logfire, but I'll answer generally. So obviously the Logfire integration in the SurrealDB Python SDK is new. Logfire isn't new, but it's not, well, Sam, you can answer that better than me, but it's, I think the thing that Pydantic is most famous for is the code and linting.
So Pydantic validation has been around for a long time, since 2017. Yeah. Logfire is new relative to that, perhaps not quite so new in AI years. We came out of beta, I guess, a bit more than a year ago with Logfire, and we were public before that. Pydantic AI is actually the newest of the things we do. It's been out for just over a year. It came out in December 24.
Awesome. Hope that answers your question. So, Martin, let's jump into building hybrid search and seeing how that again links into Logfire and the Pydantic functionality in the Python SDK. We're going to jump right into your code now.
Yeah, let me share my screen. Go.
So for people who I didn't explain it, so hybrid in terms of this demo is looking at vector and graph, combining those two together, effectively building knowledge graphs. And the reason for that, effectively, if you want to get the best retrieval, the best results in AI or for your agents, you want to be able to combine some kind of vector search, because vector search is facts, so facts that I know about a particular topic. Graph is memories or knowledge, as it were. So graph and vector combined together gives you the ability to bring out facts and then memories that have been stored. And you can do that efficiently because you don't have to traverse massive lists of tables or large markdown documents or documents themselves. You can pull out facts. You can relate from those facts to other documents and things like that. So, Martin, go for it.
Oh, sorry.
There you go.
There is. Yeah, cool. Yeah, you can actually even make it more hybrid by including full text search if you wanted, and relations and documents and everything, right? Since we're multimodal database,
and time series and temporal on top.
And time series, yeah, exactly. But don't start adding everything. Just try to optimize one at a time.
I think it's safe to say most developers start with vector alone and then go into graph and then go from there.
Yeah, exactly. And so first I'm going to start by showing Surrealist. This is our GUI. So you can use Surrealist, as you can see here, to see the schema of your database. Even if you don't have a schema like I do, you see the dotted borders means I am running schema-less tables at the moment. And here you can see I have a chunk table with some embeddings. and I have also concepts with embeddings, and I am creating graph relations between the chunks and the concepts. Here within Surrealist, you can also, of course, go in and look at the data itself. There's a bunch of stuff there, also metadata. I'm using SurrealDB for the knowledge graph, but also to store some metadata like this. I am using flows to keep track of which records I have chunked, which records I have inferred, and so on. And also you can, of course, run queries. So at the moment I am using a demo database with a couple of small documents. And here this is SQL-like query, doing a graph query. So basically I'm just getting all chunks and concepts that are related with each other. So you can, for example, here see you have this concept of statutory instrument connected to 5 different chunks, right? So it means you can do vector search against concepts and then get the related chunks. Or you can just go and do vector search directly to the chunks, which are also vector embedded, and use the concepts to trim down the graph. If you want, for example, to embed time awareness into your graph, for example, mark each document by its month or year, and you only care about 2026, then you know that you can trim this tree, leaving only 2026 documents, for example. And so that's what you can get with hybrid vector and graph. Depending on the use case, of course, if your graph may have completely different edges. So here, this is a very, very simple one, where my only edge mentions concept. So I'm only putting together concepts with chunks. But you can have very complex use cases where you want actually to infer relationships. And so it means you don't have like a finite number of relationships, but your LLM is going to analyze PDFs, for example, and infer relationships that it will find in your data. So again, don't follow this as a golden rule for creating knowledge graphs. It completely depends on your use case, your data, and the type of questions you expect from your users or agents. And let me show you some other queries. I have some interesting queries as well, just to show you the complexity of things you can do with SurrealQL. So for example, this query helps me find, like an analytical way, find concepts that are appearing in more than one chunk. So you see everything is connected to at least 2 different chunks. So this helps me like identify, okay, is the LLM actually inferring concepts that make sense? It looks like it makes sense because they are very highly interconnected, but sometimes you have a system prompt that is very bad and it just infers concept that they are completely unrelated to anything. So having a query like this, an analytical query like this, helps you understand your data and also experiment with how you are generating your knowledge graph and figure out if you need to change system prompts or your edges or types of nodes and so on. And similarly here, you can see a different but similar query to look concepts that are appearing in more than one document, not in more than one chunk, but within documents, sorry. And of course, yeah, you can have completely different examples. So I'm switching to a different database. Let me see if this. This one is based on a academic or research paper. So it's just a huge PDF. So it's just one document with a lot of chunks and a lot of concepts. And I actually stopped the ingestion worker before it finished inferring all the concepts because I didn't want to waste a lot of tokens on this. But you can see each use case can generate a completely different knowledge graph, right? And in the same way here, you will see concepts. And in this case, it's finding people mentioned in the paper, maybe the authors themselves or people that have like references or in the footnotes and so on. So maybe for this case, you actually want to fine-tune your system prompt to infer different types of nodes. And maybe instead of concepts for a research paper, you want to add like actually the authors or universities or things like that. But yeah, so just wanted to show completely different knowledge graphs.
A topic I'd love to touch on, maybe not now, but towards the end of the demo is, we've talked about kind of improving system prompts, improving the graph search, improving the queries. And that relates to detecting errors or detecting things that can be improved in production as it's happening, or so that you can improve it as your kind of users are using it. So maybe not now, but if we could touch on how does SurrealDB and Logfire help you do that, to find issues, to find areas to improve as you're running in production.
There's first, using Logfire for me is like night and day, because it gives you very good visibility into what's happening, especially with the tool calls, and you can actually see what the complete context the LLM got and the response. So sometimes without that, it's kind of difficult to see the context that the LLM was using.
Yeah.
And sometimes the system prompt is correct, but the context is wrong. So Logfire helps a lot with understanding each tool call, what was the context that was provided, and the LLM as well.
It's important, right? Because I think a lot of developers are kind of, they're building these systems quickly, and they're calling APIs, and they're hacking at it, but they don't have the full insight into where to improve or what's happening and where things are going wrong. So it's definitely something that a lot of us can improve on.
Yeah. Another thing I actually tried at the beginning of working on this demo was to use SurrealDB to store some like analytics. So I was trying to actually score my LLM calls, and with a very simple like 0, 1, or 0.5, depending on some like parameters I was setting. And I was storing like actually the input to the LLM call and the output and giving a score. So you can actually run a query on your database to see how well you're doing. So this can like calculate an overall score of like 87%, and then you change the system prompt, run this again, and you see if you improved from 87 to 90 just by having your own like heuristic way of assigning a value to whatever you are asking the LLM for.
Now we're getting competitive with Logfire's eval functionality, but that's cool. I mean, that
probably I'm going to put this into the bin for the evals, because it was actually just when starting the example itself, and this is very rudimentary as well.
But it makes sense, and I can see entirely the power of being able to have that graph view of connected principles within usage of your LLM application, whether it be looking at it particularly with evals or with production data, but like understanding the like structure of how different concepts relate to each other and how they are grouped is super valuable.
Yeah, definitely. And so now let's move a little bit into the code. So this, for example, is a complex SurrealQL script. This is doing the hybrid search that Toby was mentioning. So here you can see we have like a initial query that gets passed as a parameter here for another one. So this is actually grouping and flattening and doing a lot of data transformations inside the database. So you get it almost ready for the LLM on the Python side. So here you can see this is our vector search. So I'm getting just top five chunks, and then I am getting the related concepts. So sorry, I'm getting the concepts, and then I'm getting the related chunks.
Could you just explain for those of us who are not SurrealDB experts? I'm like comfortable. I'm familiar with Postgres's arrow syntax for accessing attributes of JSON data, but I see here, and I saw in your previous query, the arrow's going the other way, and my head is exploding. Explain to me what's happening when the arrows are going the other direction.
Yeah. So basically, here you can see I am looking at the concept table, right? And the direction of the mentions concept edge is from the concept into the chunk. But since I am starting from the concepts, I need to do the arrows the other way, because I'm basically traversing the edge on the opposite direction. So the edges are bidirectional. So you can just switch the arrows the other way, and then you get the other side of the edge.
And an edge in SurrealDB is a completely different table. So we have dot notation for accessing embedded objects, embedded arrays, or JSON data effectively.
Yep.
And then the arrows effectively are completely different tables. You can also jump to different tables with dots, albeit they're not full bidirectional edges. So those arrows, you can go right, you can go left, or you can actually do both with arrows on both ends. That's actually traversing into a different table, which you can go recursive and you can go as deep as you want.
Yep.
Exactly. And here, this is an example of the dot notation, right? So once you get a chunk, you can actually just retrieve the ID, doc, and index of that record on that other table. And then once you get the chunks, you can just do a map and basically create a new type of object that has an index, a concept, a chunk, a document, like IDs to those, and a score. And then that goes into a different select query, where then you can group by, get the max score, right? So basically what I'm doing in this whole query is making sure that I don't have repeated chunks, because if I am reaching at concepts and multiple concepts point to the same chunks, I only want one of those chunks, and the one that had the highest score on the initial vector search. Right, so this is just one example. Each use case will require something different. And I've seen from the community members a lot of examples and queries that are really, really interesting, because there is a lot of built-in functions you can mix and match, and a lot of things you can do. On the ingestion side, let's go first here. I'm doing just a very simple, like, declarative approach, so that I can just pause and resume and retry, and even re-ingest or recalculate chunks and concepts. So I did a very small, like, function decorator. So basically, to define that this chunk function should run over the document table only if it hasn't been stamped yet, and with a priority, and in this case, no dependencies. So we'll run as soon as there is a document that hasn't been chunked. So basically, it's going to poll the database to find documents that haven't been chunked yet. And I have a chunking handler that at the moment is using, I have a factory here, but it's using Kreuzberg, which is an open source Rust package to just parse PDFs. And it has also...
Just out of interest, what are you using for the chunking? Is that all implemented in your own logic, or is that...
for the moment, I'm using Kreuzberg converter, this one.
Okay.
So it's doing, I think, recursive chunking at the moment. And it has an option to do OCR as well, but I have PDFs with selectable texts. And yeah, it's really, really good.
Right. We should update our examples to use it, because I wrote a very hacky thing that I know has bugs to do this, but this makes sense. Now I have to remember how to spell Kreuzberg, but that's another issue.
Yeah, no, this is really good if you're looking for like a completely local open source solution, and if you're parsing PDFs, right? If you're parsing Markdown files, I'm not sure if Kreuzberg would be the best one, okay. But yeah, there's a lot of things, and with Markdown, since you have very clear definition of what headers are and tables are, you can also do very intelligent chunking, very easily as well. And this repo is also up there, open source. I think we're going to share the link as well. It's built in a way so you can create a factory of those converters and try different ones. At the moment, it's implemented with Docling as well, and Kreuzberg. And yeah, so Kreuzberg is running here. Once it does the chunking, it updates the table by stamping it with the hash. So this is the function hash. So it means that if I change the implementation of this handler, then the hash of the own function will change, and it will know that it will need to recalculate the chunks, right? So I'm storing that the function hash, this whole function hash, in the database itself to know, like, basically which version of this function was used to chunk this document.
Nice.
Again, because I'm basically building this first to have a nice demo, but also to be able to experiment and try different things and be able to see what's working better, which I think it's also a really good practice to do this in a real case scenario, because I think a lot of the things you want to do is experiment and then have a nice observability tool to see if you're actually improving or not.
Yeah.
And then on the after chunking, I basically now look at the chunk table for documents that haven't been inferred to generate the concepts, and I then run this inference handler and again update the records. And the inference handler is just calling an LLM. Let's see if command click gets me to the point where I have some system prompts that tell the LLM what I want, basically to generate some concepts that can be used to describe it, and don't provide explanations, etc., etc. Things you can actually improve and do a lot of system prompt optimizations. This is one thing that you can observe in Logfire, because this will be part of the context, and you can see in the agent trace this actual prompt, and then you can change this and see how it produces completely different results. And let's see if I go back now to the other side, the agent. This is very similar to what Samuel already showed, defining a couple of data classes just to make everything type safe. This is my agent. I'm not using the gateway.
It's just worth just saying here, yeah, you've done it. In some ways, your example is rather more comprehensive than mine. You have instructions when you define the agent, and you're using agent depths, which is a super powerful way of having access to, which I think may have been in the example, but I skipped over. But like, yeah, so this is just a data class, but we're just defining the depths type when we define the agent, and we pass it in when we run it, and we have access to those depths. I think I lost Martin there. I don't know if that's just me.
Probably an internet. Here you go.
I'm still here. Yeah.
So
yeah, here you go.
In there.
Back.
Yeah, makes sense. Sorry to interrupt. Go ahead.
No worries. Yeah, and actually this is really well implemented because it's completely type safe as well. So you know if you're passing the wrong dependencies and so on. And the instructions, again, yeah, this is, in this case, this is something that works really well for me sometimes, to not ask follow-up questions, because sometimes the LLM, it's very proactive and is offering things that you know it's not going to be able to do, and also not part of your use case. So sometimes really simple instructions like this work really well. And then this is the retrieve function, which is marked as an agent tool. So this agent knows that to retrieve documents, it should use this function.
So the point is here that the doc string is being parsed and passed in as we'll see this in a minute, I guess, in Logfire, but like this doc string will become the description of the tool. The args here will be passed as well, and so the call context and the search query will become the descriptions of the individual parameters for the tool, which all helps the LLM call the tool most efficiently without you having to do lots of work to like individually add those descriptions elsewhere.
Yeah. I have a personal project actually where I am using predefined functions that I need to transform them into agent tools. So there is like a specific way, right, that you can actually specify the description and the schema of your arguments in case you're
this is the like slightly magic version, but yeah, exactly. Like if you're not doing the magic version, you can also hard code them.
Yeah, the magic version is my preferred one. And so yeah, this is pretty simple. Here is the query. I have
it's worth just hovering on line 79 on the DB you will see on the left, and you'll see DB should be an instance of the database because we have run context there as the first argument, run context parameterized with deps. We know it's going to be an instance of deps. If we pass the wrong deps here, we will get a typing error because of the agent is generic in the deps type, all of which is just to say, like, when you access db.embedder on line 84, you're getting whatever that is, nullable of whatever it might be, right? And and if we would get a typing error and a runtime error, obviously if these were wrong. So this kind of stuff is useful for humans and completely essential for AI when they're writing code.
Correct. Yeah. In this case, this database is like a wrapper on top of SurrealDB SDK because I'm adding a lot of like util functions there, like to embed and insert directly and things like that. So this one is actually part of that. So I'm actually running the query. Passing the connection, the query, then the parameters or the values for the query. And this is my hacky way to actually have the query itself validate that the result is a valid search result. But there are now better ways, actually, since yesterday, because we added Pydantic integration to our SDK. So now it's much easier because SurrealDB now record IDs and SurrealDB values are completely serializable into dictionaries and base models and data classes, thanks to Pydantic core, actually.
Thank you.
And so basically this is the part. As you can see, it's just a very simple, almost 100 lines of code to get an Pydantic agent working with SurrealDB without integration. So the integration basically is just putting them together. You don't need like a middleware in between. And
let's see it running.
Yeah. So let's go here. I have like a pre-run here just in case, but let's do this. Hopefully I'm connected to the right database. This is a research paper about LLM memory. There you go.
Nice.
I was able to do it just in one try, so it only had to call the retrieve tool once. It says agent memory, external agent center persisted. There it is.
Very nice.
People can agree, people can disagree with what LLM memory. I think those words were invented very recently to have universal consensus. But here, basically, this is what you will see. This is, again, a previous run, probably the same prompt anyway. But here you can see, let's see if you can get some nice context. Right. So what I like about this is that you can actually see the full input. Or is it?
You probably want to go to the top one, yeah. The system input is relatively concise in that case, but if you open the retrieve tool on the right, just above on the right, if you click there, we should be able to see how the descriptions have come through. On the individual fields and which fields are required.
All right. Yeah. So as you can remember, this part here was in the doc string of the tool itself, and this is inferred from the arguments. So that's how the LLM knows exactly what to pass as a search query. And if I go back in time, let's see. Not sure how much. I want to see like a random call to where I infer the concepts. I'm not sure. There will be just random thing. But I just wanted to show the system prompts. But this is probably there's a lot of chunking, but not sure where the the inferences.
There's one tip that's worth knowing. If you click Shift whilst you're opening a trace, you'll see the whole thing will open. It's not very clear. When you click the plus, if you have Shift, it will open the whole thing, not just the top level, which is very useful but not very clear. But yeah,
nice. It's good to know.
I think what this shows, the main thing is, look, you can trace everything. You can see everything that's running. And I think very few teams have that insight into, or the ability to have that insight into their production AI applications at the moment. There's one thing to add, which is a lot of the stuff we've talked about today is looking at the Python code itself. And in a way, it's auto magic in terms of how Logfire actually handles a lot of this thing. We haven't really touched on how it's doing it, but at the end of the day, it's open telemetry. So you are able to also connect to Logfire with SurrealDB directly through the open telemetry protocol and any other system that talks that as well. So in addition to what we've demonstrated today, you can plug in every single part of your infrastructure to bring in that information into those LLM calls and those application calls and those client-side calls.
Yeah.
This is one of the examples where you can see actually the system prompt and the full context. So if you're doing system prompt engineering, this is what you will want to see changing, and then the output. And here you actually can see when I am inserting that in my analytics table, giving it a score.
So we've got one question from the community from Vadim. It seems to me that embedding for search currently works worse than BM25. It produces less predictable results. I think it depends on the setup of the index, but I think that's definitely something we can look at. I think what's important to say is combining vector with graph is one way of improving your results, but also combining vector with full text search is another way that large-scale enterprises are improving the kind of accuracy of the results they're bringing out. So that's something we can look at in a future stream.
Just out of interest, when you're combining free text search and vector, is that an and or an or basically scoring them both and then kind of combining the scores?
You can do both. So ultimately, we're pulling from two separate indexes separately and then combining them. But yeah, you can use and or you can set the different weights, the different important the different weights for each index separately. So Vadim, we can look at that in a future stream. Another comment from Justin Foley: Graph is life. Honestly, I say this every time, that the developers who haven't yet realized the power of what Graph can bring. It's amazing, and when you see a developer kind of go from traditional relational databases to combining graph in some form, whether that's through a graph database which is just graph, or whether that's bringing graph into your relational or document space, and when you see their mind kind of click and say, well, I actually can visualize this data in a similar way to how my mind visualizes data, it's amazing to see that transition. So yeah, Justin, absolutely agree with that. We've just gone past the hour mark, which is probably our longest stream we've done so far. So this has been great. I think there's a lot for people to learn from this stream, and we'll share the code as well. So Samuel, Martin, thank you. Samuel, anything you want to add just before we leave?
No, thanks so much for having me. Would love to come back sometime, perhaps even better prepared than I was today. And we've got some other really exciting stuff coming down the line that I think will be both interesting to your users and relevant, kind of like related to SurrealDB. So yeah, thank you so much for having me.
Awesome. Martin, Samuel, thanks so much. And for everyone, we'll look forward to seeing you on our next stream. Thanks so much, and have a great day.
Thanks so much. Cheers. Bye-bye.
Thank you.